this week. Aram Jivanyan joins us this evening from BeSafe to talk about some interesting crypto technology and proxies. We're going to learn all about it. It's going to be a lot of fun. We're going to do Paul's printer hacking adventures, which is even more hilarious than it sounds. Some funny stories in there and some great stuff. In the stories this week, I guess we got to talk about the big headlines. Marcus Hutchins, we got to talk about that. We're going to talk about Salesforce and what happened with some of the researchers at DEF CON. Mm-hmm. We have to talk about, what else are we talking about? If you're ready for a pen test or not, attacks against assembly lines, and Microsoft issuing some out-of-band security patches. Is that pretty much, is that jive? I'm getting a very curmudgeon-y look I think from Jack Daniels.
Maybe one or two that I forgot to add in, which I'm going to do now.
Okay. And more from Larry. All that and more on to this edition of Paul's Security Weekly.
This is Security Weekly. For security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. Brought to you by Logarithm's Netmon Freemium delivers real-time network visibility to quickly identify emerging threats in your IT environment. Netmon Freemium is a free commercial-grade network forensics and traffic analytics solution. You can use Netmon Freemium's powerful capabilities to search against all observed network traffic, identify abnormal traffic patterns and application usage, and quickly analyze full packet captures. Take the first step towards real-time network visibility. Visit logarithm.com/freemium to learn more and download it today. The SANS Institute, the most trusted source for computer security certification training and research. Visit SANS.org to explore their full curriculum and latest training offerings. NetSparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. NetSparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com.
And welcome to Paul's Penis Weekly. Let me introduce your host, the master of penis, Paul Asadorian.
Welcome, everyone, to Paul's Security Weekly. That joke in the beginning will make sense once Jack stops dropping his phone and once I deliver my technical segment.
Yes, it will.
Because it's hilarious. And
yes.
I'm very excited about it.
And it's a great way for you to improve your penis. I mean, security.
Yes. Penis security, same thing. You'll learn why that is in just a few moments. Here with us in studio is the security expert.
Wow, I reserve that title for you, my friend.
Larry Pesci.
We were joking before the show that, you replace penis with security, like we used to make fun of movies.
Replace security with penis.
Right? And then it would be Paul's Penis Weekly, and it would be a really short show.
Yes. Yes, it would.
Is that WEEKL or WEAK?
I think there's medication for that, Jack.
Weekly.
Yes.
Either way. Speaking of Jack,
he's here in studio dropping his phone incessantly. Welcome, Jack.
What? Where? Oh, hey! I'm in the studio with you guys. That's kind of cool.
It's awesome.
He doesn't sound like he's too convinced about that.
Yeah.
What is that? Is that your binky?
This is Suffering Bastard, my traveling companion.
Oh.
He and I travel the world.
I thought it was your traveling butt plug, but okay.
No.
You should give it a sniff.
But he travels the world with me, and he's a terrible wingman. He gets the ladies, and I end up going back to the hotel alone a lot. It's nothing like
does.
traveling with a block of wood and coming back to your hotel room and seeing a towel on the door. It's like, what the? Sleeping in the car again. But anyway.
I worry about you, Jack. I really do genuinely worry about you.
Oh, yeah. Yeah.
Good.
Yeah.
That's definitely a couple of nights with hotels.
He's got some scratches on him, so I started using the line after I hand him to somebody. It's like, he needs a little tongue oil.
Oh.
Speaking of scratches,
Speaking of spirit animals, Jeff Mann is here with us. Welcome, Jeff.
Hey, how's it going, guys?
there's-
All good curmudgeons have to have an alter ego. This is mine.
It's very nice. Did you get that at like the Disney store, the not Disney store? Like what? Do I
No,
want to know?
I got it at the HP VIP party in Vegas.
Oh, they were handing out stuffed animals.
Yep, they're handing out the wolf.
The
So
wolf.
I'm Mr. Jeff Man. This is Mr. Wolf Man.
Got it. Wolfman. Glad
nice.
we got all that cleared up
it's Wolfman Jeff as opposed
before
to
we
Wolfman
started
Jack.
the show.
There you go.
Yeah.
Couple of quick announcements. Make sure you check out itpro.tv. They've got, excuse me, a supervisor portal where your manager or your employer can go sign up for an account. They can use our discount codes, itpro.tv/securityweekly. Use the code SW30. Get 30% off for the lifetime of your active monthly subscription. And then assign training modules to you. Keep track of your progress on training. And hopefully follow my advice and give you more time to do training because training is important.
Absolutely.
That's my message that I like to add on there. So, with that, I would like to welcome our special guest this evening, Aram Jivanyan. Is it Jivanyan or Jivanyan?
Jivanyan.
Jivanyan, I thought so. Okay, Aram Jivanyan is here with us from BeSafe. Aram, welcome to the show.
Thanks for having me. Excited
Aram,
to be here.
yes, we're excited to have you, Aram. How
On the
did you
other
get
side
there?
of the ocean, right?
So, where are you located?
Now I'm in Yerevan, Armenia.
So you're actually in Armenia. Okay, I wasn't sure if you were
Yes.
your offices were there. That's awesome. Well, it's nice to have you, Aram. How did you get your start in information security?
Actually, I started from cryptography, and I started to do cryptography research since 2009, because I was just too excited of politics, and I wanted to build an electronic voting system, and a voting system which enables voters to vote and verify whether their vote was compromised or not without breaking the confidentiality of the vote. And this led me to cryptography. So this is how I started to do cryptography research
Very nice.
about seven years ago already.
Excuse me. And so you've gone on to start a company called BeSafe. And
Yeah.
explain to me what proxy re-encryption rather is. What is proxy re-encryption?
Yes. So we have founded a company called BeSafe.io, which goal is to make it easy to send to collaborate and send end-to-end encrypted files over modern cloud applications. And the problem is modern cryptographic techniques such as PGP or OpenSMIFE, they are not suited for modern cloud collaboration. They highly limit how the encrypted data can be shared. Because they are based on public key cryptography, which enables collaboration only for limited patterns, such as when Alice can send the encrypted file to Bob, or when Alice sends the encrypted file to set of recipient known in advance. But PGP does not enable to send to encrypt file and share easily when the recipient set is not known in advance, or when it's confidential, or when it changes over time. So we are building our key management based on proxy re-encryption cryptography, which is a new cryptographic algorithm invented maybe 10 years ago in MIT University.
I like how that in cryptography and encryption times, that's new, 10 years. It's very nice.
Yeah, exactly. Because a lot of methods that we are using, actually, the standard methods have been invented maybe at the late 17th or the beginning of 18th, right? The RSA and the Diffie-Hellman
Right.
crypto system. So proxy re-encryption is a new type of public key cryptography where the semi-trusted server called proxy server can take a ciphertext, encrypt it under one user's public key, let's name it Alice. So the proxy server can take a ciphertext and alter it without decrypting it. So the resulting ciphertext can be decrypted by the second user, let's say Bob.
And
So imagine a scenario when Alice, for example, encrypts all his files and puts it in Dropbox. And at the moment when he wants to share it with Bob, he just creates a proxy key specifically for Bob. After which, having the proxy key, the proxy server, in our application, it is our servers, BeSafe servers, they are enabled to provide access to the Alice encrypted files to Bob.
now, so does Bob have to send his public key to do that re-encryption?
Exactly. The Alice should know Bob's public key in order to create the proxy key for Bob. The proxy key is generated by Alice by using Alice's private key and Bob's public key.
Gotcha.
After which, Bob can take any ciphertext encrypted under Alice's public key, send it to BeSafe server, and get the re-encrypted version back. The re-encrypted version can be already decrypted by Bob's private key.
That's
This
pretty
is
cool.
how actually it works.
Right.
So if you don't mind, I can even share my screen to show some very basic stuff, how I am sharing the encrypted file via Slack. So Slack, and you can see how our Slack bot just manage access for the encrypted file for all channel members without needing to touch the file, without needing to perform any cryptographic operations for granting access.
Gotcha. Sure.
Uh-huh.
It depends on which Skype machine you're on if you're able to share your screen or not.
Should I try now?
You can try. I don't think it's going to work though because of the Skype machine that you're on.
Okay, let's try. Tell me if it works or not. Can you see my screen?
No, we can't. Yeah, it's because we're using the media version of
Okay.
Skype TX.
Okay.
It actually doesn't let you
Okay.
share your screen.
No.
Okay.
We can try and get you back on another Skype machine if you want. We can talk amongst ourselves while we switch you to a different Skype machine, Aram.
Okay. So let's continue. Let's continue without sharing screen. I will just try to explain.
Okay, we can do that.
Now the question is, will his camera come back?
Yes, it did for John the other day. 'Cause
Okay,
John
good.
tried this. John's like, "Oh, let me just share my screen really quick." And we're
No.
like, sorry about that. We just learned today that Skype machine does that.
Damn it.
Well, because it's made for broadcasters to bring people on to the show. So
Right, audio and not screen share.
audio and video, right?
Audio and video, not screen share.
yeah.
Damn it.
And this is a step forward for us.
Yes, apparently so.
All right.
Thank you, Microsoft. 2 steps forward and 3 steps back.
I don't think "thank" is the word you
As
wanted to
always.
Nope.
put in front
Definitely
of
wanted
you.
to search and replace that with my postscript.
So should we continue or?
Yeah, try if you disable your video and then re-enable it. Sometimes they get you back. So right now we're just seeing the Skype icon.
What about now? I just restarted the video.
Sometimes,
Okay.
Jeff, your thoughts on this technology while I wait for Aram to come back?
I'm waiting to see the pretty pictures to try to get a better idea of what he's talking about. I'm also looking at their website now and trying to read up on it. Well, all I'm reading is 2 paragraphs. I need to find the details.
Yeah. I think he's going to give us a demo of the details.
I hope so. I mean, what he was saying about public key cryptography is basically, it's good for what it was intended for, which is not, high-speed data transfer at the speed of the web. So if you're trying to do high-speed, fast encryption, that doesn't lend itself. We sort of figured it out with SSL and TLS, except for we didn't because it's all broken. But well, he's back.
Hello.
Here.
And so I'm back.
Yes, let's try sharing the screen now. Now it should work.
Okay, let's try.
Hey, there we go.
I see my screen. Oh, great. Okay, so you see my screen. Actually, this is one of my Dropbox folders, and actually you can see that all my files are encrypted with BeSafe, and they are safe now. So let me just go back to my desktop. I have one encrypted file here. Oops, I incidentally double click, and you can see just when you have BeSafe encrypted file, when you are logged in, they just like and behave just regular files. But now I just wanted to show how sharing works. So I have one file. This is one of my favorite books that I'm reading now. I'm right-click, and you can see on the context menu that for each encrypted file, I can I can look at permissions and access analytics. So you can see that this file it does not share with anyone at this moment. Let's get back to the desktop. I'm just taking this encrypted file and uploading it to my Slack. So the file was uploaded, and you can see that our bot, BeSafe bot, took it from there, and now it's managing decryption access for all channel members now. And voila, you can see that it's done, and all channel members got access to this encrypted file. You can manage access from your portal, which means we already can see that about a dozen people got access to this file, which is the book of Chris McCormack, I'm Here to Win. You can see that some people, some access are still pending because these are not BeSafe users. The others are already granted access. Those are already BeSafe users, and they are in my circle of trust. I can revoke any access anytime.
So, Aram, did you trust the Slack channel and say if anyone has BeSafe that's in the Slack channel, they can decrypt this file, or did you have to allow those individual users manually?
Actually, it's just a subject of implementation. But now, we assume that when a file is shared in some channel, it is assumed that all channel members should get access to the file.
Gotcha. Okay.
Except Slack, so we just want to enable end-to-end encryption. So we want to protect our files from third-party service providers getting access. So we protect it from cloud breaches. We protect it from snooping government. We just make it easy to share and collaborate within our team.
Right. So you didn't have to add all of those users' public keys to the document. The BeSafe service took care of all that.
Actually, I should have all these people to my circle of trust. In BeSafe, from user experience, you just add them to your circle of trust, let's say to your contact list, which from cryptographic point of view means that you create proxy keys for these users.
Yep.
As soon as they register to our service, and you can get the public keys and you create the proxy keys. But this is a step which should be done only one time, after which you can easily share any encrypted file with anyone from your circle of trust. This is how it works. And we designed BeSafe to preserve native cloud collaboration experience for any cloud, whether it's Slack or Dropbox. And moreover, we want to preserve the interoperability of clouds. So for example, imagine you put all your stuff in Dropbox in encrypted form. Of course, you should be able to easily share it via Dropbox, but you also should be able to share the encrypted file from Dropbox instantly to Slack, and it should work. You should not, your encryption software should not be online all the time to manage access. And you should not perform any new cryptographic operations to grant or revoke access to file anytime.
Now, what happens if the user's public and or private key pair, or I guess they would both have to change? What happens if that changes?
So you mean when the user changes public or private key?
Correct.
In this case, you should regenerate proxy keys. You should update the proxy keys as well. So if you are in my circle of trust and you just rotate your keys, it means that the proxy key should be changed as well. In that case, I should do some crypto operations to renew the proxy keys.
Do you get a notification that someone in your circle of trust has changed, their key has changed?
Not now, but this is something that can be easily done later. So we are still pretty in early stages, so lots of development still needed, but
Gotcha.
BeSafe, yeah, but it works actually. You can encrypt any kind of file, whether it's Office documents, PDF documents, video files. BeSafe now is integrated with Dropbox, Slack, and Google Drive.
Mm-hmm.
So you can collaborate in end-to-end encrypted way over these cloud services. And now we are building the enterprise version of BeSafe. And by the way, we have been accepted to Techstars Accelerator program, which will start in September.
Nice.
We have been accepted to Paris program, and we hope to build the enterprise business with Techstars.
Excellent.
Awesome. Jeff, questions for Aram?
A few. What public key algorithm are you implementing?
Actually, this is the proxy encryption algorithms. This is a new type of public key cryptography. So it's specific public and private keys.
Mm-hmm.
The theoretical algorithm is based on the crypto researcher papers of Matthew Green and Giuseppe Attanis. It's MIT and Johns Hopkins University researchers.
Okay.
But this is actually the novelty. It's not standard RSA algorithm or Diffie-Hellman are not based on standard.
Okay.
This is
where can one read up on it, or what should I Google to learn about
it? Yeah. Just Google proxy encryption, and you will get the papers the most.
Okay.
It requires specific elliptic curves implementations, actually, pairing-friendly elliptic curves. So there's a lot of mod there. We are using basic cryptography libraries, open source libraries done by it's called Miracle Library. It's again still research in the research mode. So.
Right, but
not very famous. So we are a pioneer company bringing this to industry. So you cannot find much libraries on this yet.
Okay, so it's a variation of public key cryptography, if I'm understanding correctly, and you're really trying to solve the problem of what I would call portability of files. You're trying to move files around. You're trying to make files available for collaboration. And in the old days, you would have to exchange keys with every recipient, and you're solving that problem, right?
Exactly. Okay. Because the collaboration patterns have been changed since. When PGP, for example, PGP was designed in pre-cloud and pre-social era, right? It cannot provide the flexibility and the efficiency of sharing and collaboration that modern cloud application provides. So,
right.
Jeff,
to
to answer your previous question, I'm sure you remember that in the paper from 1998 by Blaze, Bloomer, and Strauss that proposed the notion of atomic proxy cryptography, which is what it's based
Oh,
on.
yeah, I have that right over here on my bookshelf.
I'm not surprised.
I have an autographed copy.
And it's autographed.
I'm actually also not surprised.
And I'm bullshitting you.
No, atomic proxy re-encryption, I believe, was the first version of this kind of algorithms, but which doesn't actually it has some security drawbacks. For example, in this scenario, what we have Alice, we have Bob, and we have the proxy servers, right? And we want Alice to create a specific proxy key for Bob, which should not imply that there is automatically a proxy key created from Bob to Alice.
Right.
This is a security property not ensured by the algorithm of Blaze, not ensured by the
You're
atomic
still
proxy ring.
implementing the one-way functionality of public key, right?
Yes.
Yeah. So.
But with a group. So in other words, instead of just allowing access like I would in an access list, it's actually at-rest encryption that's based on whoever you add to it has access to that.
Well, it's a one-to-many rather than a one-to-one, but it's not reversible, and you're relying on some other method of validating or authenticating every member of the group. You're not solving that problem. You're making the assumption. If they're in the group, they're allowed to be in the group. They have a reason to be in the group.
Exactly. Actually, what we want to do, we want to build a key management platform which can be easily integrate any existing access management system.
Mm-hmm.
So
that was going to be my
even
next question, and open-ended. Tell us about your plans for key management, which you already started to.
So you're asking about the...
Well, tell us a little bit more about your key management schema.
Oh, yeah. So we are building a public key infrastructure but based on proxy re-encryption algorithm, which basically means that, again, each user of BeSafe has its own private and public key pairs.
Right.
Our server should enable the user to access his application and his encrypted file from many devices. And for doing this, actually, we protect the private key with the user password key.
Okay.
So, which means that the user has a secret password which should not lose or should not forget. Otherwise, he will lose access to all his encrypted files.
Right.
But we never get the user password. We never store it on our servers. What we get just the salted hash of the password. And the password is used to protect the user private keys.
Right. So, so it's similar to PGP or
right.
Exactly. This the same way. But
and the secret key is always going to be in possession of the user, the client. You're not storing secret keys anywhere.
Exactly. This is the essence of providing zero knowledge security, so-called zero knowledge security, which means that our servers should never get access to any sensitive information of user, either his files or encryption keys. What we get, we only learn the public key of the users and the proxy keys, which neither of them can use to decrypt any information of user.
Right. You're re-encrypting for the intended recipient, group member.
Exactly.
Yep. Yeah, this reminds me very much of the solution that I had to deal with in enterprise when we would do full disk encryption back when full disk encryption was starting to just become a thing. Was that we'd have the user that could decrypt and maybe the admin user that was responsible for managing them, as well as an organizational unit key that everybody in the organization had access to, assuming they went to the break glass. scenario.
Yes.
But this is sort of that organizational type of key mentality, but being able to do it dynamically. Hey, tomorrow Bob needs to be able to access all of these things. Well, great, add his key, and it's done.
Yeah, and there is no need to touch all encrypted keys, which should be shared with the new user. There is no need to perform file-specific cryptographic operations for sharing the file.
Yep. So my question would be, and I know you sort of showed the administrative interface for the individual files. I'm assuming it's also very easy to revoke those proxy keys.
Exactly. You have a circle of trust, which means you just have the contact list of the user. You can just remove anyone with one click from anywhere, from your just having web connection.
Excellent.
It's like when he's like, "This is the circle." of trust.
So removing
This is you,
removing
this is
proxy
you,
key.
and this is moving outside. Yes. Yes.
That was in a movie.
Meet the fuckers.
Meet the fuckers. Yes.
Yes.
That's pretty awesome.
And to show the potential of proxy re-encryption, actually, I like to bring the example actually of building a end-to-end encrypted social network or end-to-end encrypted Twitter. So let's assume we want to build an end-to-end encrypted Twitter. So we have thousands of followers. The followers should be able to read our tweets, but not the servers, not the social service. Could we implement it with current crypto technologies? No. Can we build it with the PGP? No.
Not dynamically, no.
Yes, so imagine you have thousands of tweets and you just add the next follower. You want him to be able to read all your tweets. What you should do, you should come back and re-encrypt for all your previous tweets for this new follower. Of course, it's not practical. But with proxy re-encryption, you just create a proxy key for your no follower, meaning and you are done. He will be able to access all your tweets.
I like that. That's
Well, and I think in the age of cloud computing and in software as a service, platform as a service, this is immensely useful.
Huge.
Right? Because you don't want to, and that's the reason I think people are skeptical about moving to the cloud, so to speak, is they don't trust the cloud provider, right? And this would help with that transition because now you decide who you trust with your data because it's encrypted and providing an easy way to manage it. So that's what I got out of it anyway. I hope I'm on point there.
Agree.
Because anytime we start talking about Alice and Bob, you see all of us like with that look on our face, like we're thinking, we're like noodling on it.
Yep. Yeah. Alice and
I
Bob.
even saw Jeff do some noodling over there too.
The little smoke comes out of the ears.
I want to know when Carol and Ted come into the conversation.
That gets really complicated.
Well, see, that's the thing, Jeff, is that Carol and Ted should never come into the conversation.
I think they should.
Yeah.
Otherwise, we have to rename the movie.
That's right. That's a good point.
Yes.
Any more questions for Aram?
Yes, I have another question. Many, many years ago, I don't want to get into a long story, but let's just say PGP has an issue in terms of being able to compromise the key rings and just basically stealing the secret key off a client. How have you guys addressed that or solved that risk?
I'm not sure I'm familiar with that specific attack, but the protection of private keys actually is something that should be cared by the user itself. So now we just enable the user to store. We just don't get the private keys, don't store it on servers. We just ask the user to protect his device.
Okay.
So can you provide some specific of the attack?
Well, it's what I've been kind of thinking about lately. It's kind of like the gas station attack. I think they, in a similar manner, if you're going to douse yourself with gasoline and light yourself on fire, then you're going to do that. And there's really not much you can do to prevent that. The same thing, you can't really prevent someone from not putting a password on their private key or sharing it publicly on GitHub. Oops. I don't know if there's anything there with my gas station analogy, but
Other than sometimes you are a gas station.
yes, that is.
Well, actually, that's more Mark than any
It is. Mark is the master in that department.
master gas.
Things have gotten a lot better since we switched to cocktails from beer, because in the beer days, especially when we were in the little studio in your basement, that was lethal.
gas station.
The gas station, all right.
Less than desirable.
Well, Aram, so people can learn more at BeSafe.io, and you said you're in an accelerator program. Congratulations on that. And
Thank you.
we thank you for sharing your knowledge here on Security Weekly.
For those that are listening, can you clarify the spelling of BeSafe?
Just be safe. B-E, safe.
Got it.
So the idea is cloud
it
is
could
not safe. We just want you to be safe with us.
Because it could be the letter B safe. It could be B dash safe. It could be
like those-
BEE safe. So I just wanted to make sure those who were listening and not necessarily reading.
It's just be safe.
Got
be
it.
happy.
None of those fancy spellings, like when everyone used to leave the E out in words.
Web
that ended in
2.0, that'd
Web
be-
2, remember the
yeah.
Web 2.0?
Yeah, we now do Web 3.0
where
where
are-
English is important.
Yes.
Where are all those E's?
Yeah. Someone stole them all.
E.E. Cummings used 2 of them, but
Right.
it's before the internet. Never mind.
Aram, thank you very much for appearing on Security Weekly. It was
Thank
nice
you.
meeting you.
Thank
Best
you very
of luck.
much, Paul. Thank you. So
Thank
see
you.
you next time.
Thank you.
Absolutely.
Thank you.
We are going to take a short break, come back, and I'm going to do a tech segment on my printer hacking adventures coming up next.
First, I need another drink.
And